Let us come to our fourth unit, compiler design. This is Dr.P.Ezhumalai, Professor and Head, Department of Computer Science Engineering, R.M.D.E.C College. Today, let us see this lex and deop concept. First, we will see the outlines of the lex and deop. The lex, what is the theory, how the program is executed, what is the example. Similarly, deop, what is the theory, description about the deop and example. Both link the lex and deop link demo. Let us see that. Lex is a program that generates lex converter. Lex is a tool which is used to generate lex converter. It is mostly used for YARP process data. It is written in the header subject and MyPace. It reads the input stream and output source code implementing lex converter, the C programming code. Lex is a tool which is used to generate a lex converter. Okay, Lex will read the patterns and produce a C code for the lex converter that scans the identifier. Similarly, lex is a sample pattern. For example, letter within bracket letter or digit closer is an example for variable recognize. Okay, the regular express are translated by lex to compiler that mimics and final state automata. This pattern matches the string or character that begins with a single letter followed by 0 or more letters or digits. See that start with the letter followed by letter followed by start here. First letter should be first input should be letter followed by letter or digit followed by another characters. It is so. Lex scan as a program start go to state 0. It comes here. Read the character. If the character is a letter, go to state 1 again. Again read the character. If the C is a letter, go to the state 1 again repeatedly. If C is a digit, go to the state 1 again. Repeatedly you do this. If it is end, go to the state 2. State 2 accept listing. It is a recognized character. Starting should be letter, followed by letter or digit will be accepted in a character variable. Some limitations, Lex cannot use a recognized nested structure such as parenthesis, since it is only states and a translation between the states. So Lex is a good at pattern matching, while York is for more challenging task. Lex. Any meta characters, not any character except new line, /new line, star 0 or more of the preceding exception, plus 1 or more copies of the preceding expression, question mark 0 or 1 copy of the preceding expression, expansion, and beginning of the line, dollar end of the line, A or B, A plus B closer, 1 or more copies of the A group, A plus B within the quotes, double quotes, literal, A plus B is escapes will be the characters for the character class. So this is a meta character of the Lex program. Similarly, Lex ABC matches for ABC. ABC closer and C is a closer. C may be repeated 0 or more number of times. This example. C is 0, C is 1, C is 2, C is 3 times. A plus B, A, B, C plus. Similarly, 1 or more. A will be 1 time or 2 times or 3 times. 1 time, 2 times, 3 times. Similarly, A followed by BC plus. BC plus will be 1 time or 2 times or 3 times. A, BC, BC 2 times, BC 3 times. Like A, BC question mark. A will be at least 1 or followed by ABC 1 time. ABC, one of the ABC from A to Z, any one letter from A to Z. A slash hyphen Z. One of A hyphen Z. It will be looks like A to Z. So hyphen A Z. One of the A, one of hyphen A comma Z. This is 0 A to capital letter Z to small letter to 0 to 1. So these are all the expressions. These are matches the lexical laser. So see the pattern of the lexical. Definition section. First section will be lex and lex will be definition section. Is a separator. Rule section is a separator. Code section. 3 sections will be one Lex program. Let us see the input structure of the Lex. First, the first section. Echo. Echo means what you are typing, it will display. Slash a new line. Echo. What is your type to that? Will be display echo character. So first is close. Is a separator. Next section. Linked. Waiver wrap void. Open parenthesis and close bracket and 1. So whatever written there will be getting written one types. Integer void main void Lex and bracket closer written 0. So it matches for the your definition section, root section, and code section. Okay, user YYLex file called invoke lexer returns tokens. Character YY starter text pointed to matching string. YY length of the matching string. YYL value associated with the token. Integer YY wrap wide. W wrap up return one if done, 0 otherwise. So file output file, input file, initial start condition, begin, echo. So these are the lex name, these are the functions for the lex. So similarly, the program digit A to 0 to 9, letter A to capital letter Z to small letter Z. So first is plus integer count to be started is separated for the different declaration. So rule section, letter within bracket, letter or digit closer. Okay, we count plus how many count we are doing here, that should be count plus is separated. Integer void main program, YYLex should be called printf number of identifiers. First is the count will be counted here. So return 0. The white space must be separately defined with the associated expression. The code of the definition section simply copied it with the generated C file and must be brace with the percentage of course. So similarly, Yap program, Yap reads the grammar and generates C code for parser. The lexical answer, Yap is a parser. The grammar written with a backwards nouns form. Okay. DNF grammar used to express the context-free languages. To parse an expression, do reverse operation. Okay. This is known as bottom-up or shift-based parsing using stack or sorting info. The input into the app divided into 3 sections: definition, roles, and subroutines. So these are the definition section. Token declarations, C code bracketed within like this, C code is written, root section, brackets normal form grammar, context by grammar, subroutine, user subroutine to that section. User context by grammar. Left line is a non-terminal followed by non-terminal or terminal. Similarly, all these expressions are given. Program expressions are non-terminal. Program, the EXP are non-terminal. ID and terminal are terminals. Tokens written by the lex. The expression may be sum of two expression, product of two expression, or an identifier. Similarly, see that the next file. Percentage. Let's definition next will be started here. Hash include standard file will be included. YY characters, character will be started include y.tab.h. So declaration section will be covered. Then start the input section 0 to 9 plus. So the rules YY value equal to ask it to integer YY text, return integer value. What you have written there, so that will be integer value written. Slash icon slash new line, return YY text, what is space will be there. Slash T tab will skip the white spaces. YY error, invalid YY error will message will display. So is the root section will be closed. Subroutine section, integer YY wrap wide. So return one. If it is correct, will be written in the correct places. So YAP file as include standard one YY wide YY error character only. A token integer. So declaration section is a root section program. So program expression will be there. The expression will be integer value assigning plus or minus. So addition subtraction can begin. So in the main program, so wide YY character plus not in this one. F printf, file print F. So standard error. If any error is meant, this error on the listing will be displayed. Otherwise, the main program wide will be called YY pass will be called return 0. Successfully completed executed this program, return 0 to main program. So similarly, linking lex and YAP. YAP program base.y, next program base.l. So it is entered the YAP compiler. Okay, so it is entered the lex compiler. In between these two transactions, y.tab.cat file will be included both. So output of lex is lex.yy.sys, ly yylex. YAP output is y.tab.c, ypass. So both are combined in C compiler. So the output of this BAS execution, the execution file will be generated. The source program we are giving here, compile target program will be output. So lex and YAP included only lex analyzer and parser. So thank you for listening this video.